Hello everybody and welcome back. So we're going to continue today with the second part of the classes discussion, and I'm starting from where we left off in the last lesson, exactly as we were, so you can probably follow along with the same scene file if you still have it saved. So we were creating our human class, and we've used some magic methods inside of here to create a few functions. For example, how to initialize our instance of a class, how to represent it when we print it, or when it's printed inside of a list or something like this, and then how to add this either to another human or to another to an integer or a float. Now what we're going to do is we're going to look at a few other methods that we can do inside of this class. So not just magic methods, but actual class functions that can be run on instances of that class. Now remember, we've discussed before that because Python is object-oriented, it's kind of a way of simplifying the list of possible functions that you have at any given moment. Because if you had access to every function of every object in your scene, all as just global functions, it's very, very confusing. There's tons of options, and therefore it's hard to know where to begin. So in Python, your functions are kind of grouped under your classes. So any method that we create here inside of the human class can only be run on an instance of the human class, and therefore we don't have access to that function in any situations where that function is not applicable. Right. So this is kind of the purpose of creating them now under the class, is the fact that we can basically group together all functions that would need to operate only within the context of this human. Right. So I'm going to create a few functions over here for this human to be able to perform. Now, before we do this, I just want to point out that, all right, so we've done these magic methods, but remember we spoke about having internal properties. So previously we just used the myval. Now, what I'm going to do, just for the purposes of our functions that we're going to create, I'm going to actually create a kind of a global variable, so a property under this class, where every human, no matter what their age and name is, when we instantiate it, we will have an energy value of 100. Okay, so we're talking about sort of a percentage here, 100% energy. And then what we're going to do now is we're going to create a bunch of functions that are going to run, and every time the function runs, it's going to either add or subtract from this property. So because we're setting energy to 100 in the class, that means that each instance is going to begin with 100 energy. But then we're going to run functions on that, so then our instances will have their own energy levels altered, either added or subtracted to, and then the instance will carry a different energy level to the actual default that's in the class. Right. So I just wanted to do it this way so that you can kind of see why we would have some properties that are created by actually initializing using data given here, or possibly, I mean, we could even maybe create a self.height and randomize that between a certain range. So although it's not based on information given by the user, it is random per instance, and it is created at the initialization stage. But something static like the percentage of energy that they have is something that we can define just loosely inside of the class like this, right? So not inside of our init function. Okay. So what we're going to do is we're going to create a walk function, right? So we're going to create this function, and what we're essentially wanting this to do is reduce the amount of energy, okay, by a small amount. Now, as I've said before, the first argument of all of our methods is going to be self. Okay, so we have a reference to self, to the instance of the class when we run this function. But then I'm also going to give a second optional argument here, which is duration. because if you walk for 1 minute, that could be considered a walk. But if you walk for 3 hours, the amount of energy that it takes you is going to be vastly different to how walking for 1 minute did. So the duration matters essentially. But what I'm going to do is I'm going to give it a default value, a duration of 1. Well, let's say 1 is 1 hour. Okay, so you go for a walk, you walk for an hour, but you might want to walk for even longer. Okay, so we're going to create this function. Now, what this function is going to be doing is just altering this energy level. Sure, there could be other properties in here, like we could maybe even have like almost like in Houdini where you have a point position. We could actually have a position, and so when you walk from one position to another, it would actually alter the position. So there's lots of things you could do here, but I'm kind of thinking about this, did you guys ever play the game The Sims? This kind of thing where you've got this energy level, and then if you do some action, then it reduces energy but maybe increases your fitness level or something, and then if you have to sleep to recover your energy level, but then your fitness goes down or whatever. So you can kind of build a little human like that. In fact, if you want to practice creating humans, I would actually suggest doing something like that. Almost, use The Sims as a bit of a reference, and kind of just, make it fun for yourself, because it's a way of making things very memorable. As if you make it kind of fun and entertaining, you'll start to get to grips with what you can do with it. Right. So there's lots we can do with this, but all I'm concerned with here is the actual amount of energy. Now, remember that we're not wanting to alter the energy that the class has, but actually the instance of it. So we are when we tell Jimmy to walk, we want Jimmy's energy to reduce, not the whole of humanity, right? So we're going to now say self.energy, because it's the energy property of the instance of the class, and we're going to minus equals a certain amount. So let's say 10% of energy is lost for every hour that we walk. So if that is for every hour, then we're going to want to multiply this amount that it's reduced by our duration. Except that here we have a duration of 1 as a default. So if we just tell him to walk, then he's going to lose 10% of his energy. If we tell him to walk for 10 hours, then he is going to be dead. Right? So we do that, and then let's create another function called run. So run is going to basically do a similar thing, and we're also going to even give it a default duration, but we're going to say that running burns a lot more energy. So energy minus equals, and let's say it takes away 20% times the duration. Okay. And then let's maybe do something like, so now we've got two things that can burn energy, but maybe you want to recover this. So we want to rest, right? So again, we've got self, we've got duration, and when you rest for an hour, now we're going to add, so self.energy plus equals, and then let's say it's 10% times the duration. And then as a final function, let's allow them to sleep. Now the sleep by default is going to be 8 hours, because most of the time when people just sleep, they're going to sleep for a certain set duration, and nobody really just instantly automatically sleeps for an hour, right? But people don't run for 8 hours unless they really are determined to run for 8 hours. So if you just say, I'm going to go for a run, that generally means you're going to go for like maybe an hour. So that's why I've chosen a different value here. So I'll say sleep so we go self.energy plus equals, and again, this is, let's say let's go 10% times the duration. So it's kind of the same as resting, it's just that you would, the default is different. Okay. And then, yeah, that should be enough, right? So for now. So now we have these internal functions that we've built for this, and it's going to alter this energy level. Okay. So when we create this class, so let's actually use this. Let's clear all of this. I mean, we've created two humans. Now let's print x dot energy. Okay, so when I say that, when I click apply, it prints 100. That means we have 100 energy, 100% energy on Jimmy because it was instantiated that way. Okay, when we create it, it has exactly 100 energy. But now, if I say, now remember, to run these functions, we have to call the instance of the class, right? And these functions will only be accessible if we are running them on an instance of this class. So if we had something else like z equals and then something else, I don't know, let's just create an integer, okay? We can't say z dot run because there is no, this is an object which is an instance of an integer class, okay? That class does not have a function run. So when you say dot, it's looking inside of the class that is associated with the object type, okay, the data type, and running functions inside of that data type. An integer does not have run, but human does because we've defined it in here. Okay, so this is how Python basically keeps these functions organized inside. So now if we say x dot, well, let's start off with walking. Okay, so if we walk, and now after that we print x dot energy, you'll see there we now have 90. Okay, so Jimmy went and basically took a walk and lost 10% of his energy because by default it's 1, and so we didn't give it anything in here, so it says that. But let's say we say, well, actually he goes for a walk for 5 hours. Okay, that's pretty intense, right? So now he's pretty beat. He's used half of his energy. Okay, now you see every time I click apply, it didn't take 90 and then subtract 50 from it. It's new every time because it's running this entire set of code. So it's recreating Jimmy over here and then having him walk for 5 hours and then checking his energy level. It's now, if we run it again, he's not going to be at 0. If I click apply, it's going to be at 50 again because it's running this all in one go. Okay, so because of that, now if we want him to rest or something, we would now have to go here, x dot, and then rest for maybe 3 hours. Okay, so now he's back up to 80. Okay, and maybe we want to be a little bit smarter here and say, okay, because this is very confusing seeing all these numbers, so maybe whenever we actually run one of these functions, we want it to kind of report back a little bit of information, okay, so that we can kind of keep track of what's happening. So inside of here, let's maybe do something like, say, well, print, and then let's just say that he walk, and then we'll give the amount of energy that was lost or something here. So dot format, and then should we say, well, if we want to do the amount of energy that he has, then we can just say self dot energy. Okay, alternatively we could say how much energy was lost. So we could actually say, well, let me just show you what this does first. So if we just say self.energy, it's going to print how much he has left. Okay, so it's going to basically say, it's like us, instead of having to print x.energy over here, we would just be always returning. So if I take this and then under rest, we go and say, well, now he's resting, and then we print self.energy. What it's done is when he took his walk, he's now at 50%. When he rested, he's now at 80%. Okay, but instead of that, if we want to maybe say, well, let's get a bit smarter with this and show how much energy was lost or how much energy was gained, then let's say in here, so we say walk, and well, we'll put energy lost. So such amount of energy lost or certain amount of energy gained. Okay, but now we have to calculate this. So we're calculating how much energy is lost, but we would be better off storing this in a variable. So we would just say, and we would just call it loss or something like that, equals. Now remember this, whoops, let me paste that correctly there. This is just an internal variable. This variable exists inside of this function. So this is not accessible outside. It is not going to live on this level. It is not, I'm not going to be able to run x.loss and find out what the loss value is. This function, this variable, lives only inside of this function, and at the end of this function, it ceases to exist. Okay? So you need to be very careful of that. If you want variables to exist outside of this, then you have to define them up here. You know, if we altered energy, we could pull it in here, alter it, and then outside this would be changed. But if we just create something inside of here and never pull it out or never define it as a global variable, then it will be lost. Okay, and that is good. That is what we want, because we don't want to hang on to these variables and have to clean them up at every step. Okay, inside of a function, we just want to be able to create a variable, do what we want with it, and then let it just disappear. Okay, so now here, the format that when we print, we would just print how much energy was lost. Okay, and then we would do the same thing here, right? So let's just call this gain, and then we'll enter this in here, and then we'll just swap this for gain, and we'll swap this for gain, right? So now we say, well, 50 energy was lost, 30 energy was gained. And if we wanted to, we could even say equals, and then tell them how much energy we actually have at the end of that activity. Okay, but then we would we could go self.energy, right? And then self.energy. Cool. So there we are. So now he's lost 50, so he's now on 50. Here 30 energy was gained, so now he's on 80. Okay, and so on. So now we can do the same thing with these other functions. We can just print the same thing in here, but we just say run. Now I want to just point out something very important of why I'm defining this as a variable instead of just saying this, taking this 20 times duration and just inserting it here. Okay, or even inserting it in a variable, referencing that variable, but still just leaving this here. Okay, and it's because there's almost a principle in coding that we need to get used to, especially before we now move into working through with actual coding examples, is I want you to understand that basically a really good coder will almost never repeat anything. Okay, so when you are going to define something, if you're going to take this single number, a certain multiplier multiplied by this duration, okay, so like a certain base number multiplied by this, you want to do that calculation once, and then you want to reference it multiple times. Referencing things is fine, but you never want to do this calculation again and again and again. Okay, not only is it slower, well, I mean, in this case, it's really, really quick, but imagine if you were doing a very difficult operation. You want to do that once and then just reference the result. But also, it's easier to change it. If we now decide that running actually takes more than 20% of your energy, it takes 30%, right? Well, we have to come and change it here, but we've got to change it everywhere else. And the odds of us finding all those places later on is a lot harder than just storing it in a variable and now referencing that variable wherever it matters. Because then we can just change it in one place and it alters it everywhere that matters. Okay, so this is a very important lesson on how to streamline your code so that you are more efficient in the future. Okay, so here I'm going to do the same thing. I'm going to print this, but we'll copy this gain in over here, and we'll swap this for gain. Okay, and then we'll say sleep. Right. So now we can do that, but we can tell him to do a variety of things. So maybe he rests. So now he's got 80% energy, and now we send him for a run. But maybe we tell him to run for, let's say we tell him to run for 10 hours, right? Well, that's pretty bad because now he's gone into negative energy. Okay. He's lost 200 energy and he's now in negative 120. Well, that is not good for people, right? So we would then want to be a little bit smarter as well inside of here and check. You can actually reference the amount of energy that we have and check it inside of here. So when you run your function, you want to then say, okay, maybe after calculating the loss, we can then calculate the difference, right? So if we say, so we'll just call it something like delta. So because delta means like the loss, like the change in amount. So if we take self.energy minus the loss, right, which is what we're going to do here. But this is actually committing that change. Here we're just checking that change. So we're checking the delta, right? And then we say if delta less than 0, right? So if after subtracting the amount of energy lost, it would take us down to 0, then instead we can then do something. I don't know. So you could return from this function and maybe print something, print an error. So Jimmy basically complains saying, I'm too tired. Now, you see here, this is that thing where I want to put an apostrophe in the word I'm. We need to use a backslash, a forward slash. Wait, is this a backslash forward? I never remember the difference between the two, but anyway, this slash to cancel that, right? So this is all a string, but this one has been escaped as not a special character. It's just a normal character. Okay, so now he's going to complain saying, I'm too tired. And then we're just going to return from this function, which means we're not going to do any of the rest of this. So it's not going to print how much energy he lost or gained, and it's not going to actually commit the change in energy. He's just going to say, nope, sorry, you're telling me to run for 10 hours. I can't do that. Right. So now when we click apply, right, nothing's going to happen. Oh, sorry, I forgot here to say print. So we say print this amount. So in amongst this function, it's going to print a value, but then it's going to return from that function. So we tell him, okay, go take a walk. So he takes a walk, loses 50 energy, takes a rest, and then you tell him to run for 10 hours, and he says, nah, I'm too tired. Right. So you see, now this kind of touches a little bit on a principle that we're going to work with a lot later as well, which is you need to think what the user is going to do with your functions. If you're defining functions and classes and creating your own code like this stuff, because we're working with classes and functions, these are things that can be worked with by other people, including yourself. Even if you're the only one using it, you need to treat your future self as a user. And here is something, I mean, honestly, guys, write this down. This is game changing for coding, right? The number one, the golden rule is that your users are idiots. I know that sounds funny and that sounds silly, like you shouldn't, but the thing is, you have to imagine that your user has no idea what your code is doing. Even if it's you that's using it in a month's time, I guarantee you won't remember the intricate details of how the code is working. And so you're going to go and enter some random value that doesn't make sense, or you're going to try and run it on an object type that doesn't interact with that function. So you have to test for this. You have to try and put yourself in the shoes of someone who has no idea how to use this, and then you have to make this idiot proof. Okay, that is the true mark of good coding, is when it cannot be broken. When you attempt to break it, it will complain, but not just complain as in, say, error. When you get those like Windows errors where it just as like error code and then just some random thing, like some generic error. And even when you Google that error code, it's basically just like, it failed. Like, that is useful to nobody, right? It doesn't tell you why you used it incorrectly. It doesn't help the user move forward using it correctly. They just now think it's a bad tool because it broke. But actually, they just fed it into the wrong thing. So you need to try and build your code to be a little smarter. So here, we're checking something because if the user tries to tell this human to run for way too long, then he complains, but with a very specific complaint, saying, I can't run that far or that long, okay? And we're going to do, I know this is a little bit of a funny and playful example, but really what we're going to be doing is a lot of this later on, is looking at all the possible ways that our code can be broken or misused. And we're going to be building advanced ways of telling the user, whoa, okay, you just did something wrong. You used the code in the wrong way, but here's why. Here's what you did wrong, and here's what you should be doing. And try to point them in the right direction, or even prompt them. You know, if you run a tool that requires a node to be selected, now what if the user has nothing selected and they click the button? If your button just does nothing, they think the tool is broken. Whereas when you click that button, expecting them to have a node already selected, and there's nothing selected, it pops up with a message saying, please select a node. Now they know that your tool's not broken, they just know that they did something wrong. And you've told them what to do next. So this is a very, very important principle for coding. Creating dynamic error messages that are actually useful to people. Thinking of all of the possible scenarios and ways that they could break the code. Assuming that they are going to break it, because they absolutely will. And yeah, just basically just trying to make your code foolproof, because that really is the mark of proper coding, is that it cannot be broken, or at least cannot be broken easily. I mean, I imagine there will still be some really bizarre errors that will sometimes happen, because maybe something like your actual Houdini module breaks, and so you know, but that kind of deep level broken stuff, that is okay. But really, if it just comes down to basic user, you know, like errors, you should help them and guide them, or check things for them. And if there are things that cannot be, for example, in another way of doing this is, instead of saying, complaining that he's too tired, is we could actually build in a thing where we calculate how far he can run, and then tell them, okay, I didn't run for 10 hours, I ran for 3, and then I stopped because I was now too tired. So now my energy is 0, but this is how far I ran. So we can actually do things for them and calculate stuff for the user, right? And I'm going to stress this again, even if that user is you. If you're building tools for yourself, you still need to build it as though the user is an idiot, because you are going to use your tool, but you're going to use it in 6 months time or something. You know, maybe you go on another project, so you don't need this particular tool set. You come back to it later on and you click the button and something breaks. And now you've got to go digging through code to figure out why it didn't work. But all you needed to do was select a node before clicking the button. So that's what we're going to be working on when we move forward into these practical examples, is building smart code. Not just normal code. Anybody can very quickly learn Python and build, you know, tools. Just kind of very gung-ho tools that just jump in and do things, but assume that your user already really knows how the tool is working. And that is terrible. Those tools are an absolute waste of time, because even you, when you use them in the future, will forget how they were built. Right. So that kind of segues into the next lesson, where I'm going to be talking about errors and also some of these principles a little bit further, and how we can code smart instead of just, you know, coding rubbish things that are useful in the short term. Right. So I hope this lesson was useful to you, and you see how we can build up classes. So now, you know, we can create magic methods, instantiate a class, we can create properties within that class, and we can create functions that operate on that class or alter those, and then we can create instances and run functions within them. All right. So in the next lesson, we'll be talking more about errors and smart coding and that type of thing, and then we're going to wrap up this week and in fact wrap up the module and move on to our practical examples, where we're going to actually start building some things in Houdini. All right. So thank you very much, and I'll see you in the next lesson.